So we're in chapter 1, section 1-2. We're going to discuss the ideas of points, lines, and planes. Okay? Most of us have dealt with the idea of points. We dealt with the idea of graphing points in the coordinate plane. But in geometry, we don't necessarily need a coordinate plane to deal with points. We deal with points just in space. So a point is a place in space with no dimension. A spot in place with no dimension. So in geometry, we can deal with the first, second, third dimension. Right? We won't deal with any dimensions above the third dimension. So place in space with no dimension. So you can put your finger out there, just add a little slot. Okay? We're going to denote a point using a single letter. The point will just be a dot. We can call that point A, for instance. A line is one-dimensional. So one-dimensional line with arrows at both ends. Lines going on and on forever in both directions. We'll look at a few different conventions for naming lines so we can all be familiar in talking with the same language. So if I have a line, notice the arrows on both ends going on and on in each direction. Oftentimes we need 2 points to define a line. So we could name this line AB. And how we're going to name it to show that it's a line is put a little hat on it with a line. Okay? So that's how we know we're discussing a line. And it's okay to name it going the opposite direction too. Line BA. That we're referring to the same line, so we know what we're talking about. We need to create a common language so we can refer to figures and diagrams and know exactly what we're talking about. Oftentimes, though, you might just see a line like this, and it'll say, and there, and we'll just call that line A. So most commonly, you'll see it referred to with this 2-letter convention, but it can just be have a single letter associated with it, and then you can say line. And sometimes I don't want to talk about the entire line. Okay? I just want to look at a small part of the line. So a small part of the line is the line segment. So a part of a line that has endpoints. And how we're going to define that, I want to look at just this segment, this part of the line. So we have just that part on this case, segment AB, and you can go backwards. BA. Notice we have the line on the top, but there's not arrows going up in both directions. Meaning we're just talking about part of the line instead of the whole thing. All right, so a ray is also part of the line. But a ray has a starting point on the line, and it goes on and on forever in one direction. You can have a ray by itself, or you can have a ray that's a part of a line as well. So array is that starting point that shoots off in one direction. It's important to note that with our shorthand notation for arrays, we can't go backwards. Right? The only way to name this array is AB. Right? The first letter gives us our initial point, our starting point. And then this letter determines direction. You can have two arrays with the same starting point that go in different directions? Sure. What did I create there? An angle, right? But notice we have an array here and an array here. This tells me the starting point. This tells me the direction. So this red one would be array AC. Starts at A, goes through C. And we determine which one we're looking at. Very important in math classes that we're all discussing the same. It's somewhat simple, but we're creating that foundation. And then opposite rays. Whoa, it's a long one. Two rays that share an endpoint and go in opposite directions. If we have the same starting point and they go in opposite directions, we just have a line. So opposite rays. AB, AC are opposite rays. A very common mistake people make when they're first dealing with geometry and this notation. This always goes to the right. The arrow on the top always goes to the right. First letter gives us our starting point, second gives us direction. Okay? You can't say AC and give it the opposite direction. That does not tell me it's going the opposite direction. This always goes to the right. Next, the plane. Not something you need to write on to go to Hawaii, but a two-dimensional surface. So the plane takes us that next dimension. Okay? We have a line with one dimension. A plane has two dimensions. So I like to think of a plane as your flat piece of paper, right? But if that flat piece of paper just extended in all directions forever and ever, that's a plane. It's a slice of the world. We discuss planes in terms of the surfaces of three-dimensional objects. So say you want to look at this Chromebook part, right? This top here, if you extended it on and on in all directions, that would be a plane, right? And the intersection of two planes, okay? We have two planes that go on and on forever. I don't know what the intersection would be. We have two planes intersecting. The intersection of two planes is always going to be a line. So where they cross. Next idea. Well, actually, let me get into the naming conventions for our plane. So a plane we typically draw looking like this. In order to name a plane, we need to use three letters. And three letters will define a plane. right? The key is those three letters have to be three letters that are called non-collinear. 3 points are non-collinear. That means they're not all in the same line. So if we have A, B, C, if they're 3 points on the plane, that are not collinear, you can define a plane. So you can just use the three letters. Whatever you see those three letters, you know that we're talking about a plane. The other way, we can define it just like a line. Then you have a little other letter here in space that does not seem to be associated with any particular point. We can name that plane. We see that letter in the corner of the plane that's not associated with the point. Then we can define a plane. That would be the same plane N for that. And I said non-collinear, right? But we haven't really discussed what collinear means. They don't have an idea what collinear means? Yeah. Two points, no, not quite, 2 points, right? That are on the same line, collinear, right? So we have, hey, come here. So 2 points, 2 or more points that are on the same line, segment, or ray. That's what collinear is. And non-collinear, as we said, just doesn't do that. And so they're not on the same line, segment, or ray. Anyone have a guess what coplanar points are there? Yes. Okay. Not points on opposite lines, but co and then plane, right? Points on the same plane. Points on the same. Okay. Collinear points are points on the same line. Coplanar are points on the same plane. And so we dealt with intersecting lines in Algebra 1 and found that the intersection is a point. But intersect means that two figures have at least one point in common. They can have more than one point in common. So if we have two planes that intersect, the intersection is going to be a line. What about the intersection of a line and a plane? What do you think that's going to look like? So if I took this paper, and had this pencil as the line, in space, the intersection of a plane and a line, it's going to be the single point. So the intersection of a line and a plane is going to be a point. Unless, right? What if that line lies on the plane? Okay. That intersection will be all points on the line. Okay. So think about how things collide, intersect, and what that would look like. All right, so take a second and see if you can do example 1, and we'll go over that. So do example 1. We'll go over that, and we'll wrap up this lesson. All right, let's see how we did. So name 3 collinear points in here. Anyone have an idea of 3 collinear points? E, and F. And remember how we denote points? Simply by the letters. It's D, E, and F. Right. A single letter denotes a point. Name 4 coplanar points. How about all of these guys? D, E, F. And then we're going to add name 3 points that aren't collinear. How about G, E, and D? Are there others? Sure. And furthermore, if I wanted to name this plane, could I name it plane DEF? Would that be a good name for the plane? No, right? Because these guys are collinear points. And if they're collinear, they could be any plane if we rotated along that line. So this would not suffice as defining that plane. However, we could define this plane as plane GED or GEF, right? That would work, right? Because those are not collinear. So they form that triangle that can define that plane. All right, next. Draw 3 non-collinear points, J, K, and L. All right. I'm going to do J, K, L. All right. First step, check. Done. So draw JK. There we go. This is a line. In your notepad, you have KL as a line as well. Yeah. Yeah. So we'll change this to a line here. So KL. Both directions, and then LJ. It's just going to be a segment. That connects those two. That ends in both of them. So LJ and JK. I hope you enjoyed this math video. Tell your friends.